what are the benefits of containers, where does Linux fall into that. We'll move from there after establishing kind of that baseline to really what is Kubernetes. We're going to talk about container orchestration and really how Kubernetes is a platform for our OpenShift container platform. From there, we'll move into a bit of a high-level overview of OpenShift, and then we'll talk about what kind of training options we have at Red Hat as far as helping you to foster your container adoption. And at the end, we'll have time for Q&A, so make sure to add your questions throughout in the question box, and we'll have time at the end to answer some of those. So, first and foremost, what is a container, right? Hopefully, you're coming into this webinar. You probably have heard about containers as sort of the cutting edge technology. This is the next thing. This is where everyone's going to be deploying their applications. But digital transformation, and that's kind of a buzzword, that's been around for quite some time now. But it's really kind of what software companies are referring to when they talk about moving their workloads from bare metal to the hybrid cloud, or moving away from your more monolithic applications towards things like microservices. Really, also, it's about changing your development practices, right? Moving from more of a waterfall development strategy towards something like continuous integration, continuous deployment. Really, from deploying from data centers to deploying towards cloud, whether that's a public or private or some kind of hybrid. But really, the goals of the steps should really be focused on, what are the outcomes? Are we, increasing speed, agility, and control, right? That's really what the focus should be. And so, when we talk about speed, it's really as it means, new ideas can be deployed faster. Agility, as it means, updates, changes can be done more simply and allow for, more experimentation. And then as far as control, as far as, the risks and security issues with, bugs or weak configurations, those kind of things can be approached and resolved more quickly. And so, this is, what we look at with new patterns for development. We also want to define a new method for integration, right? We need our applications and even the way that we approach our design of them to be more agile and to be scalable, right? To exist across, various public or private hybrid clouds, and ultimately to be able to be iterated quickly and more efficiently, right? If you look at here on the left, your traditional integration is really incompatible with cloud development, right? Modern architectures, modern application development is going to really require more agile integration. And the focus here is around, scalability and specifically reusability, but also there is definitely a culture process aspect to that as well. And I would encourage you, if you haven't really gone down sort of the DevOps, rabbit hole, so to speak, as far as changing from a culture and process standpoint, I definitely encourage you to check out a webinar that myself and someone from our Open Innovation Labs team, Matt Piccani, did a few months ago. That was all really around just DevOps as far as practice and how how you can utilize not just the process of culture piece, but how something like containers and container adoption can help you to really move towards a more scalable and agile methodology. So, what are containers? It really is going to depend on who you ask. So if you ask your infrastructure team, really it's sort of the natural evolution of virtual machines. And we'll talk about that coming up in just a little bit. From a development side, it's really a way of, packaging your apps with all the dependencies that they require, right? You no longer have to provision, multiple virtual machines that have all of these different libraries. You can now package those libraries, maybe conflicting libraries, all with the actual application itself. You can deploy it to any environment, whether it's the cloud or bare metal, and it can be easily accessible. It can be shared throughout your organization. It can be updated more and more easily, more and more frequently. So ultimately, it all depends on who you ask. But let's kind of level set, right? I mentioned as far as from the infrastructure side, it's simpler, lighter, and denser than VMs. But what does that really mean? So organizations have traditionally kind of co-located, multiple applications on a single virtual machine due to the overhead and really the resources cost of managing and maintaining virtual machines. And while virtual machines are really isolated from each other, co-located applications have zero isolation. They can be negatively impacted by each other's files or configurations or the behavior. And so Linux containers, they really share a container host and a kernel. At the same time, they're using the kernel technologies like C groups and SE Linux, kernel namespaces, and it provides an isolation so that one container can't access or impact the other containers that are running on the same host, and they can't really affect the host themselves, right? And so from a security standpoint, this is really nice because the way that you're going to secure a container is the same way that you would secure the host itself. And the Linux containers are, in a way, a virtualization technology, right? You can kind of think of it conceptually like that. Virtual machines are for virtualizing the hardware, while containers are for virtualizing the application processes, no matter where they're run. So, whether that's bare metal, whether it's virtualized, or whether it exists in the cloud. And so, when you look at these two, side by side, what's the difference, right? What's the benefit? And so, if you want to look at the kind of the benefits and the downsides to each of these, although it's possible to run every application on a single virtual machine, the overhead and the resource cost of the multitude of all these extra VMs that you're going to need generally is going to invalidate the benefit, right? And so VMs have the advantage of providing hypervisor level isolation for the application, but that comes at the cost of running a complete OS for each application, which is going to consume more memory, CPU, resources, and furthermore, VM's compute and memory capacity is predefined, and they don't provide any elasticity or agility, especially when an application requires more memory and more compute power. Containers, on the other hand, provide isolation through taking advantage of those kernel technology, as I mentioned before. So things like C groups, things like kernel namespaces, SE Linux. And these have been battle tested and used for years at all these different companies, right? Google, the DoD, big corporations or members of the public sector that have been essentially testing these and using these in the field for years and years. They've been using these to provide application isolation. And so some containers use a shared kernel and container hosts. Because they do that, they reduce the amount of resources required for the container itself, and they're more lightweight than virtual machines. And therefore, containers provide really an unmatched agility that's not feasible with virtual machines. For example, it only takes a few seconds to start a new container. And because they support a more flexible model when it comes to the computing and memory resources, they allow resource burst modes essentially, so that applications can consume more resources when they're required within the defined boundaries. So I talked about DevOps kind of at the beginning there. The DevOps adoption across customers and partners that we work with has really skyrocketed in the last few years, and that coincides with really the proliferation of containers throughout these various industries. This is not a coincidence. Containers have played an important role in enabling organizations to really implement DevOps without the obstacles that you face with virtual machines. And with VMs, their unit of compute applications are developed by dev teams. The results delivered as arbitrary packages, which usually vary between teams and applications. So they're delivered to your operations teams, which are responsible for building and deploying and managing those virtual machines. They have to manage not just the VM, but the OS. They have to manage the libraries, the application dependencies, and then ultimately the application itself. So, this creates kind of a conflicting atmosphere, right? You have your dev team, your operations teams, other teams that are involved in delivering applications, since, your ops team is forced into ownership of, maybe these undocumented or non-standard layers of the technology stack. So, in other words, the application and its dependencies, those are things that they're not going to be familiar with, and they have to rely on kind of vague instructions from their dev team. Meanwhile, containers, they're used as a unit of compute. So, there's a clear boundary between the layers of the tech stack that your operations teams and your dev teams are going to be responsible for owning and managing. And so in some ways, it allows for ownership of maybe these undocumented or non-standard layers of the technology stack. So in other words, the application and its dependencies, those are things that they're not going to be familiar with, and they have to rely on kind of vague instructions from their dev. Meanwhile, containers, they're used as a unit of compute. So there's a clear boundary between the layers of the tech stack that your operations teams and your dev teams are going to be responsible for owning and managing. And so in some ways, it allows for collaboration in ways that virtual machines doesn't really. In other ways, it provides isolation, right? Your development teams are only going to have to worry about actually developing those applications, where your operations teams can just worry about the container hosts and the infrastructure piece. So your developers are going to be deeply familiar with the application they build, as well as any of the dependencies, the configurations it needs. With containers, they own the application and its configuration and package. That's just a container image. And then those images are then going to be delivered to your operations teams as essentially a standardized package, regardless of the technologies used to build the application. And so then your ops teams will own the entire infrastructure. So, whether it's a containerized host, whether it's virtualized, whatever. And so they're responsible for running the standard container images, and they can deploy, monitor, and manage those containers across, a wide array of infrastructure, right? And they're using kind of standardized procedures without the need for, adaptation for every single application that comes their way. And so, ultimately using containers, the dev teams and the ops teams can work at different speeds. They can upgrade and downgrade servers and applications kind of independently of each other. And they can easily move applications between these different environments. And, the clear ownership boundary, it really allows development and operations to work seamlessly during the application delivery cycles, and it lays the groundwork for really enabling DevOps across the entire organization. And so, while there's been efforts to kind of standardize the VM format, it's never really succeeded. And, the VM technology is highly tied to the hypervisor. So, for example, when you're using something like VMware, the VMs on-premise are tied to vSphere, whereas in a public cloud like AWS, they're tied to those AWS hypervisors. Ultimately, moving an application to other infrastructure, if you're moving to bare metal or other hypervisors, private and public clouds, they all require rebuilding the application technology from scratch. And based on the chosen infrastructure and redoing all the verifications on the previous infrastructure, ultimately, we need to move across the entire IT industry, we need to move towards immutable infrastructure. And that's purpose is to really simplify deployment and management ultimately of the software. And so using VMs as a packaging unit for application, it requires you to build a new VM every time there's a change and you ship that to your infrastructure. And so I'll use Netflix as an example. When they needed to make a change in production, they had to bake that change into a new VM. And then they had to ship the VM to production. So, Netflix, they've stated that they would have taken a different approach had Linux containers, had that ecosystem at the time been as mature as it is today. And so as far as portability is concerned, containers provide application portability due to the standardized image format, which is the Open Container Initiative, or OCI. And you'll hear mentions of OCI throughout this presentation, but the fact that they are only dependent on Linux, it gives teams better control over the infrastructure where they deploy their applications. So you have a container host, it provides a common ground for running containers on any infrastructure, whether it's your own laptop, bare metal, virtualized infrastructure, or ultimately a public-private hybrid cloud. And nevertheless, portability does not guarantee compatibility. Portability is often believed to mean that you can take a container image and run it on any container host built from any Linux distro, and that's just not accurate. Linux container images are essentially just collections of files. They include the libraries and the binaries, which are specific to the hardware architecture and to the operating system. But when the container image is run, the binaries inside the image run just like they would on a normal Linux OS. And so there has to be compatibility between the container image and the container host. So, you know, just like with any application, you can't run 64-bit binaries on a 32-bit host. There has to be compatibility there. So, you know, these inconsistencies can range from, you know, some sporadic failures, which are hard to debug, to, you know, complete failures when the container just won't run at all. And you know, incompatibilities can lead to, you know, performance degradation, security issues. So, you know, portability of Linux containers is not absolute. You know, using different Linux distributions or widely differing versions of the same Linux distribution, they can lead to some serious problems. And so, in order to guarantee portability and compatibility, it's really just best practice to run a consistent version in distro of Linux in all containers and on all container hosts across environments and across different infrastructure. And so this ultimately just guarantees compatibility both horizontally and vertically. And so the OCI standard containers combined with a standard container host, something like Red Hat Enterprise Linux or RHEL Core OS, they provide a portable and compatible application delivery combination that, you know, ultimately guarantees your applications are running the exact same way across all the environments and all these differing infrastructures. And, you know, immutability is really one of the key benefits of these OCI standard container images without being tied to any specific machine image format like you are with VM images like AMI on AWS. That's why you see, you know, Netflix, who I mentioned before, they're adopting containers to enable the same, you know, continuous delivery workflows, but now in a more portable and efficient manner. So, you know, take a look at this slide here. You know, when you look at containers, and I'm not sure if you've been to, you know, an event that Red Hat has been at, but, you know, containers are Linux, right? The underlying OS within the container, the dependencies that require are running on Linux, right? And when you have those dependencies matching, as I said before, the underlying container host, you know, that kernel, you're really able to be more, I guess, immutable, more agile, and ultimately get the most out of every single one of your containers, and ultimately run them across any infrastructure, right? You know, everyone is moving away from just a simple bare metal environment. They're moving towards these, you know, public clouds, or maybe you're using something like OpenStack for private cloud, maybe a mix of the two. So, you know, obviously hybrid cloud, which is really where, you know, we kind of have our sweet spot. And so, you know, containers in a nutshell, right? Containers are really transforming the way that we think about application architecture and the speed at which teams can deliver on these business requirements. And so, you know, containers promise application portability across, you know, hybrid cloud environments, and they allow developers to just focus on building their applications instead of having to worry about the underlying